Then, yeah.
This meeting is being recorded.
Very good afternoon to one and all who joined for this this evening's talk. As all of you know, this now we are in 124th. 1 minute, sir. Hello.
Yeah, you are audible.
Mail, sir. That one, WhatsApp group same thing. What I sent, their link and password also this. Our scientist. Yesterday I sent. Sir, Dr. Tengli, sir, this is a series of lectures we have been conducting since last 124 months every month. Your talk is the 157th in that series. We are thankful for accepting our invitation and giving this today's talk on drones for crop health. Recently, we have started at our institute studies on drones, and we want to have much interaction with you based on your vast experience. Before you proceed for the talk on drones for crop health. Coming to for the benefit of all the participants, I welcome each one of the participants to this online lecture. Before starting the lecture, I would give the brief introduction about today's speaker, Professor Professor P.N. Tengli ji. Presently, he is the professor and head at Nitti Meenakshi Institute of Technology, Bengaluru. He is handling classes for BA and MTech courses of aerospace and defense technology students. And he is head of aerospace and defense R&D NMIT Bengaluru. And he's recently he got as a principal investigator one big project is sanctioned under his head. He is also a core team member of NAC, NBA, NMIT, Bengaluru. Before coming to this Nitti Meenakshi Institute, he was the Director General in Aeronautical Systems, DRDO, Bangalore, and he has a vast experience in different institutes in administration and research related to different missiles. Maybe he may be a little bit telling. I could see in his biodata missiles like BrahMos, NAG, and several things what we generally listen. This is really exciting to watch all of them here. And apart from this DRDO Bangalore, he also worked in SF complex DRDO Jagadalpur, located in Chhattisgarh, DRDL, a part of DRDO in Hyderabad, where he worked as a system manager for particularly BrahMos and NAG. Apart from this, he worked in NTTF Bangalore, Government Tool Room Bangalore, BML Defense Products Bangalore, and HAL Aerospace Division Bangalore. These are the other organizations where he worked as a part of his service, and a total of more than 36 years of professional experience he is having in this particular field. Coming to his academic qualifications, he did PhD in management in Andhra University, Visakhapatnam, and he worked on study on cost and time overrun in product development, a case study of the rocket motor development at Jagadalpur. Then he did PhD in mechanical engineering from Dr. MGR University, Chennai, on the topic study on the vibration problems of solid propellant rocket motor. And he did PhD in project management, University of Hyderabad, as well as he is also having the experience of doing MBA in marketing as well from IGNOU, New Delhi in 1997 itself. And he did the initial BE from in mechanical engineering from Karnataka University in 1982. He is a member of various engineering-related associations like Aeronautical Society of India and several others. And he held several responsibilities in different institutes, like development of solid propellant for Agni 5 and variants, coordination and support to labs for product development. Like this, he is having several, he discharged successfully several responsibilities. Coming to some of the awards and achievements, he got Lab Technology Group Award in 2009 for Agni Rocket Motor Processing, Special Award for Strategic Contribution in 2011 for processing and static testing of Agni 5 rocket motor successfully. And he had several certificate of appreciations and award from Inner Wheel Club. These are some of the contributions of Dr. Prahalad Tengli. Now I request that Prahalad Tengli to go ahead with his presentation on drones for crop health. Sir, here the audience comprises of mainly crop protection. Means as the topic goes, crop health. All of them will be curious to know about how these drones can be used for, particularly for spraying, or how they can be used for the identification of the problems in the crop, and how best you can make use of the drones for crop health, whether it is a disease management, insect management, or nutrient spraying, any related. You can give a brief introduction about drones, and please proceed about sharing your experiences on drones, sir. Over to Professor Prahalad Tengli, sir.
Thank you very much, Par. It was a good introduction by you. I'm very much grateful to you. And good afternoon, everyone who are participating for today's talk. And I am very much thankful and grateful to Dr. V. Sridhar, President and Principal Scientist, ICAR-IIHR, Bangalore. It was recently I visited your campus, and during that time we had a good discussion. And then later I was invited to give a talk today, and I'm really very happy, sir, for and thankful to you for your invitation to give a talk. Actually, today's talk, what I am going to give is actually we are doing this work right now, and at our Nitai Meenakshi Institute of Technology, and this is based on the project that is sanctioned to us by one of the MNC organization, and later application point of view, we are interacting with GKVK and as well as that is Bangalore Traffic Police for application point of view, because the swarm drone technology is one of the latest technology wherein this drones, they talk each other, and then whatever we give commands, so they perform they perform each other, and see that entire objectives of any work that is required to be done will be done by a group of drones, not one drone. Because normally right now in the existing technology, what is happening is normally this one drone will carry the pesticide, and entire crop it will go and see that it is sprayed on the entire crop. So, but in this case, it is totally different scenario, wherein one drone will take care of that spraying the pesticide only for the infected plants, and one drone will see its health, whether it is improved after spraying pesticide, and then later it will monitor its health until it becomes a healthy plant or healthy crop. So whereas these other plants which are very much are in good healthy condition, so there this pesticide will not be sprayed. So unnecessarily wasting pesticide and spraying on the crop where they are already healthy, so that requirement may not be there, and this will help also to maintain that really that pesticide going into all the plants, that can be avoided. So that is one of the advantage here. In fact, particular this project, we are shortly going to demonstrate also that that is images it will take, and then it will show that the plants which are infected are different from other plants, and there it will take care of this health of this crop. So that kind of technology we are developing In fact, there is a need by GKVK. In fact, they are growing the crop in some of their field for our purpose. So as and when it is growing, we are taking our drones and monitor right from beginning and see that at the end how these infected plants are protected. I think this is application based work what we are carrying out, and really the team of people visited and understood their requirements, and then we have taken care and we are incorporating artificial intelligence and machine learning, AI and ML into this particular project, and so that it will take decision whether to spray the pesticide or not based on the health of the crop. So this kind of technology we are developing at our institute. Maybe once we complete this project, I think we'll invite you, sir. Sometime you can visit us along with your team and see how we have taken up this project and executed. Already this project is in advanced stage of development, and in future shortly we are going to demonstrate this technology. At that time we'll give an invitation to you, sir. So with this I will start my presentation.
Okay,
I
sir,
will
please.
yeah. So actually this drones what I said, they are mainly especially for the swarm drone technology. With this we want to demonstrate the use of swarm drones for smart crop management. So this is the thing which we are going to adopt for this smart crop management, so that all the problems that are existing and going to be there with this crop will be addressed in this particular technology, because there is a team, not one drone, there is a team of drones which will take the command from the control station, and then later that commands will be obeyed by other drones. And also here this endurance comes into picture. So wherein once that endurance of that drone is over, so then alternate drone will take over that drone and then see that these commands are followed further. So this kind of arrangement is made. And also in case this control station drone itself goes if it is not failed or it is not working, then one of this slave drone or follower drone will take over as the master drone, and then it will again start giving commands to the follower drones, and then this task whatever is required to be done, that whole thing will be taken care for the duration that is assigned. And this entire thing which where there is a clarity that what these drones are supposed to do, so this will work in this in autonomous mode right from start till end. That entire thing will be done in autonomous mode as per the mission profile, and then it will be keep on updating the status of this activity, what is happening to the control station. Yeah, if you see this the application layer here, first we have taken as agriculture, because agriculture is going to be the future of India or future of Bharat. So this is the first priority wherever possible. These technologies, whatever this niche technologies are coming into picture, and these advanced technologies where we need to fill up the gap between this whatever drawbacks and whatever problems we are facing, so that can be addressed with this particular swarm drone technology for mainly for the agricultural purpose. So this is going to come in a very big way as a disruptive technology, so that these existing technologies will vanish, and then this will take over and to meet the entire application of the crop. And this farmer, once that seeds are sown, after that he has to just relax, and all the work whatever is being done by farmer right now, that whole thing will be taken over by drones, and this will really monitor and manage in a very good manner. And also that whatever human errors or laziness or not doing some work in between and not uniformly doing the activity, all those things will be overcome by this systematic approach of this swarm drone technology. So other applications, which one more application we are working with DGP police for this traffic control of this Bangalore. So Bangalore, where this congestion is there, and right now, whatever the systems they are having, they have shown us the control station. And in fact, some of this development in this drone for this traffic control, what they are developing with Honeywell. So that thing, what are all the gaps in that, what they could not do, that activity has been given to us. So we are also working on this smart traffic management. So these are all the two applications which we are concentrating, but first priority is given to agriculture, crop management. So we are working on this. So other applications which are identified for this swarm drone technology is listed here. And but whereas we'll now focus only on agricultural application. Okay. Now, if you see here that as this slide shows that the smart and precise agro management, how this is done. So this is leveraging the use of multiple drones. That is, I already said that this is a group of team of drones, and also these are all intelligent autonomous systems. So to effectively localize diseased crops and perform localized pesticide spraying. It's just on of the test case in revolutionized crop management. Here, actually, this is the effective management of the crop, so that that plants or crop, the area which is damaged or due to insects, so that area alone it will identify. We need not say that this particular crop is not developing or other crops are better. We need not do that. It will go and take the pictures of that particular. It will scan initially throughout the crop, whatever is growing, and then it will go to the place where this particular crop is not growing due to various reasons, and then it will take the images of that particular crop, and then later it will decide. So whether that crop has to be, how to see that this crop is made healthy. So based on this, its percentage of its deterioration, so the decision will be taken how to go for the profile of maintaining that particular crop, what is the quantity of pesticides to be sprayed, and what is the interval that has to be done, and how to monitor that its effectiveness, and see that how this is further improving at par with the other crops which are healthy. So this kind of application is very, very important. And I think this particular application so far, as per the research studies, whatever we have searched in this various publications and other research areas. So this is still it's very, very initial stage, and it is not taken up further. Maybe since India is the maximum this depending on this agriculture, maybe we can take a lead in this and then see that this application is effectively implemented. Maybe we can take up this in technology demonstration level. Maybe once it is proven, it can go for the real application in a big way. So this is the thing which we are doing right now. And if you come to the this is precision crop monitoring. This is how it is done is capture high resolution data on plant health, growth patterns, then soil moisture levels, and pest infection. So this accurately these details are taken. Then next is effective crop spraying. How it is done is cover large areas quickly and efficiently, and precisely target crop areas, optimizing the use of fertilizers, pesticides, and herbicides, and towards sustainable agriculture. So this has to be planned for improvement of this crop. And also there is another application like this pollination support can be given, can be programmed for mass pollination, enhancing crop yield and ensuring food security. I think this is the pollination support also can be taken up, but right now we are concentrating only on this crop, how that infected area can be, health can be managed. And also this crop mapping and analysis. This is a very important thing to know the correctly whether how it is how to do that and identify the only that portion where we have to concentrate. Can create a detailed 3D maps of agricultural fields by using advanced imaging techniques. So for this, we are incorporating these high-end cameras wherein continuous images are taken so that that can identify the crop for the actual good healthy crop to unhealthy crop. So that this particular thing we are doing, we are experimenting in a small scale. Once it is proven, then we will go for the next. We can scale up this and then see that required objectives are met. And similarly, this technology can be used this crop inventory and yield estimation also. This coordinated flight of swarm drones allows for efficient and accurate crop inventory and yield estimation. So this is the application. And similarly, this livestock monitoring and management also this can be used. Okay, since it is equipped with cameras and sensors, they can track the behavior, animal behavior, and detect signs of distress or disease and all that. So it can be monitored. So coming to this present scenario, the drone use advantages in agriculture. According to that recent research, the global drone market within agriculture would grow at 35.9%. So this is going to be the future, and in a very big way, this is going to grow. And this is based on this data that whatever we got, that CAGR and reach, it will reach up to 5.7 billion by 2025. So this is the that is future this scenario is going to be futuristic scenario, and this is going to happen based on the study carried out. And how in what way these are all used, these drones, whatever we are projecting for future for agricultural purpose, how we are going to use this drone use advantages in agriculture. What are all the areas wherein this can be applied? So this can be used for crop spraying as usual. I think this is already started. So entire crop in one go, this one drone will go and then spray pesticide throughout and then come back. This is already being used. And similarly, this can be used for geo fencing, and also can be used for crop monitoring, which we are going to take up this. And this further monitor the growth throughout its growth. So this also will continue with our study. And even this plantation can be done, and the soil and field analysis can be done. So this also how healthy that soil is, because pesticides every year we spray on the crop. Maybe due to that the soil may contaminate, and then we need to know how healthy that soil is. Maybe this drone will carry that sample, and then with that handheld equipment it will analyze and see that what is the percentage of this pesticide and other contaminations in the soil, how healthy it is, what is the health of this soil, so that for future crop what is going to come, if it is healthy, then it will grow better. Otherwise, that crop may not give the yield. So that kind of scenario, we can go for that also. We can take up this analysis, and also it can do this livestock management and check crop health. Health can be checked. So this as it grows, this also comes under this our study. And then avoid chemical overuse. So this is again wherever required only we should use that. Otherwise we need to optimize that usage of chemical. So this can be taken up, and prepare for weather glitches. So these are all various applications so that drone can be used, and the swarm drones, what I am saying today, can also do some of these applications at a time, not that only one by one. If it is only one drone, it can do only one application. Whereas today's my talk, what I am saying is swarm of drones, that is group or team of drones, can do many applications in one of the swarm team. So that can be simultaneously, though, that can be carried out. So this crop monitoring, as I was saying before, this is done that improved crop health assessment. That is through, in this, what we do is high resolution imaginary and data using hyperspectral cameras we use for this purpose. For improving efficiency, what we do is cover large areas quicker and efficiently. And precision agriculture. Here, area specific irrigation, fertilization and pest control will be carried out. Then cost saving, it is definitely cost saving. Identifying the crop issues early and applying intervention only where needed. Otherwise, it may not be required. Unnecessarily extra cost we need not incur. And real-time monitoring is possible here in the control station, because whatever this data we received from drone, so that will be seen and then decision is taken. So it gives the provide real-time data for timely decision making. So then enhanced crop planning can be done with the data available. That once this data is collected over multiple sessions, helps in long-term planning and decision making, because this data available in that particular area, this will be stored, and then future every year based on that progress and the data available, so that long-term planning can be done, what we can grow, or what is the health of soil, and what is to be done. All that informations are available to take a proper decision. So after this, my friend will continue about this further on this, what are all the other things that can be done using the swarm drone, and some of the technology related data regarding swarm drone will be continued by my friend Mr. Heron Thomas. Mr. Heron, can you continue?
Sir, thank you so much, sir.
Yeah, please go ahead.
Yes, sir. So now I really thank Dr. Tengli, sir, for giving me the opportunity to present this, and also all the dignitaries present today. So I'd be explaining the technological side of what we are doing here at NMIT. So to give a context, so we are specifically designing our AI and ML model for pigeon pod crop. So here, what we are planning to do is, we have a swarm of 4 drones that we are developing right now. 5th one would be used as an auto replacement. Like sir said, if one of the drone were to fail at any given point, so the 5th one would take automatic decisions, and it would replace the failed drone. Currently, we have a swarm of 4 drones that we are developing. So the drone 1 and 2 will have the visual inspection capability. So what does this mean is, on our drone, we'll have an onboard computer, which is a Jetson, NVIDIA Jetson, which has 40 TOPS, and it gives us enhanced computational capabilities. So we are using hyperspectral cameras because we, after visiting the GKVK field, we found out that the crops which are infected or diseased gives us a far less infrared radiations. So with the hyperspectral cameras, we are able to see the pod borers or the pods which are actually infected. So according to the GKVK's data, we found out that the pod actually starts growing, and once we get enough data sets in the month of November, October, say it will start, and up until November, we'll have enough timeline where we can collect the data samples from the field to train our model. So as I said, drone 1 will be equipped with high resolution cameras, and the drone can map and geo-target the specific areas of interest. So because our drones are autonomous and are communicating with each other, my drone 1 and 2 would be doing the mapping of the entire area, and then geotagging the specific areas of interest, and these data would be sent to two final users here. So the first user is data processing center, which is situated at ground control station, and the second one is for the drone 3 and 4, which would be doing the spraying. So my drone 1 and 2 will have almost same capabilities in terms of computation, flight computer, as well as the sensors equipped with it. So here, what the AI model, what we're developing here is specifically targeted to pigeon pod as of now, because that is the application what we have found. So here, what we are trying to do is classify the type of crops and the disease severity. So based on this, we would be deciding how much fertilizer, how much nutrients, or how much would be required in order to treat that particular area. So we also have sensor fusion along with the imaging capabilities to find out the nutrient level or the moisture level, and we will have ground-based sensors. If GKVK already uses, in some of the cases, IoT-based sensors to monitor the soil level, soil moisture, nutrient contents. So with the help of IoT, we would be able to directly communicate with the IoT devices which are already present in the present at the field to make a better decision. So coming to the ground control station, we will have all the data coming from drone 1 and 2 fed into the ground control station. So here, a local user who is sitting at the ground control station would be able to see all the data that is flowing in from the drone 1 and 2. And along with the autonomous layer, we would also have a manual decision layer. So here, if the local operator would require drones to do specific mapping or do a better mapping or follow a different waypoint, so it is all allowed. We will have a layer of autonomous as well as a manual decision layer. So at GCS, so because our drones will work in a cohesive manner, so our local operator would be able to control the dynamic position of the drone in 3D space. So that capability is also given to the local operator. And finally, whatever the data that is coming from the drones are stored locally, because our AI model is reinforced learning. So every time we get the data, so we are using the same data to train a model to do a better job at what it is currently doing. And again, we are leveraging the use of swarm drone technology. Whatever swarm drones that we are seeing currently in this present scenario is only used for light show, and all of the drones would have similar form factor or the size. So we are trying to disrupt that and come up with different structures of drone. So my drone 1 and 2 will only be equipped to do visual inspection, but again, the frame itself is customizable. So if the operator wants to use my drones for any specific application, so he's welcome to do so by doing a little bit of customization. So my drone 3 and 4 will have only spraying capabilities. So whatever data is sent from drone 1 and 2 would be fed into drone 3 and 4 without the need for a ground control station. So when my drone 1 tags a specific area where the pod borers population is very high, then my drone 3 or 4, this is again based on an adaptive decision-making capability inbuilt. So we would be able to autonomously spray the fertilizer, the pesticide to that specific area. So my drone 3 and 4 will have a capability to carry the reservoir tank where it can be filled with fertilizer, pesticide, fungicides, or whatever the local operator wants. And then this will do it in a dynamic manner. So how are we approaching this problem is we have a layered approach. So currently with my decision-making layer, I will have mission planning. So initially, whatever planning we are doing would be in a master drone. So my drone 1 would be my master drone, where I will feed in the data of the mission. So in the decision data is then fed into the path planning layer. Here, the master dynamically allocates the task into different drones. So it would be doing subtask planning and subtask management in order to efficiently give specific instruction to the slaves in order to perform the mission what I have fed into the master drone. So this path information is fed into the control layer. So my control layer comprises of a flight computer as well as a onboard computer. So I can call my onboard computer as a companion computer. So my companion computer would be doing task coordination, formation control, obstacle avoidance, and collision avoidance. Also, it will have a layer of redundancy and fail-safe, which will come with my flight computer. So with respect to task coordination, so the master, with the help of adaptive routing of the decision data, it would be able to instruct each of the slave drone to carry out a specific task. In my formation control, the local operator sitting at the ground control station would be able to control the attitude of the drone in 3D space. This is through an interface that is we are developing using an open source software, and we are modifying it specifically to suit the agricultural application. So because it is a swarm, so we need to have obstacle avoidance and collision avoidance, because once we visited the field, we found out that there are a lot of obstacles which are on the way for a drone to navigate through. So my companion computer will take care of the obstacle avoidance. For obstacle avoidance, we are currently focusing on the sensor-based obstacle avoidance. In the later stages, as and when required, we will be moving into a vision-based obstacle avoidance, which is again a complicated task, but again we are working on it. And as Sir mentioned, our drones would be redundant and fail safe. So each of my drones will have an onboard computer and my flight computer. So each of these computers will have their own set of sensors. So with this data, we would be always matching, and then we'd see if there is any discrepancy in the data that is flowing in from the sensors, and then we would make decision with whether the drone is operating as intended, or do we need to land it autonomously. So this interactive information is set to again fed into the communication layer. So here in swarm drone, communication layer is a crucial part for us, because every drone is communicating with each other, and one of the master drone is communicating to the ground control station. So we are taking care of the network hardware and protocol, and communication network, data uplink and downlink, and information fusion. So because only master at a time would be communicating with the ground control station, so all the data that is flowing in from the other drones would be again coming to the master drone, and from that to the ground control station. And our final layer is application layer. We are only focusing on the agriculture for now. And again, the agriculture layer is also dependent on the end user. So depending on the type of task that has to be done by the drones, the end user has a capability to change my decision-making layer in order to perform the task. So I'll talk about why the drones that we're developing why is it unique. So as I mentioned, each of our drones will have an onboard computer as well as flight computer. All of those would be autonomously operated, and it is intelligent because we are using stereo cameras with 3D depth perception to physically map my areas and then perform intelligent decisions. So in order to reroute or avoid an obstacle, this is all inbuilt in each of these drones. And again, initially we are developing just a swarm of 4 drones, but this technology itself is customizable and scalable. So we can add more number of drones as and when required once we have a stable communication and my control architecture set up. So Sir mentioned again, our drones are fail safe. And again, we are working for 2 applications here. One is for agriculture as well as smart traffic. Again, as and when required, these drones can be used for multi-use cases. And how are we going with the development of the swarm drone is we have a methodology. So initially we'd be designing the drones. So with the end user design requirements, we would be developing our drone frames on which the payloads would be again defined by the end user. So we would be doing communication setup and feasibility studies, which is ongoing right now. We are doing communication bench testing with respect to telemetry and with respect to communication with the ground control station and from drone to drone. This part is currently going on at NMIT. And autonomous system design, we have finalized our flight computer, onboard computer, and we are testing the autonomous system. We have tried out waypoint navigation as well as the initial swarm drone simulations, where we found out that our drones are able to perform as intended and as the mission was fed into. And now we are moving into, in the coming weeks, we are moving into the field testing. So again, testing is one of the most important, one of the crucial part in our entire project, where we are testing individual systems. Currently, our autonomous testing and communication testing is it's almost in the completion phase. And in the next phases, we'll be doing flight trials in the field. And then finally, we'll be doing a fail-safe systems. For autonomous flight testing, we'd be testing the autonomous swarm flight operation and as well as the testing of coordinated and synchronized flight testing. And depending on who is our end user, we'd be doing a complete operational demonstrations. So after which any specific application can be taken up. So currently, this is our specifications of the drone. So we have 5 number of drones. 4 would be working in swarm and 5th one would be auto replacement drone. And our range and endurance as of now is the range is 10 kilometers itself between the master and the ground control station, and 5 kilometers from one drone to the other. So the endurance here is 30 to 40 minutes. So that is based on the estimation and individual drone testing that we have arrived at. And takeoff weight here, I have 2 categories. So drone 1 and 2 will have 1.8 kgs of takeoff weight, and drone 3 and 4 with spraying capabilities will have 8 kgs of takeoff weight. And my payload capacity in drone 1 and 2 would be 1 kilograms, and in drone 3 and 4, where I would be doing spraying, would be of 5 kilograms. So I can carry a total of 5 kilograms as of now. And the operational altitude and cruise speed would be 5 to 50 meters, and the speed is 5 to 10 meters per second. And again, we are looking into the customizable body. So again, with very minor customization, we would be able to reprogram or reassign the drone to do any particular task. So with respect to payload and functionalities, we are working on the sensor-based collision avoidance system. That is one of the other team who is working with respect to software that is already are working on the sensor-based collision avoidance system. And for all the vision-based computation, we are using lightweight YOLO V3, and we are moving into V8, YOLO V8 architecture, where we are doing the object detection. We are training the YOLO model to detect based on the severity classes from the data sets that will be shortly getting from GKVK, as well as the traffic management. So again, as I mentioned, the payload is completely user-defined, and we'll also have auto drone replacement during flight for field-safe operation. So command and control here, we have two ways we can control our swarm. One is autonomous commands or remote control via the ground control station. And all of my flight computers have redundant sensors and integrated sensor, which also includes accelerometer, gyrometer, magnetometer, and barometer. So my flight computer itself is open source and customizable. So any sort of developments from the end user side is always welcome, because the flight architecture itself is very open source and intuitive. And we'll have real-time data, telemetry logging, and we are looking into very low latency data relay systems. Finally, with respect to my communication and telemetry, so we are operating at 914 megahertz for my control signals, and telemetry is 433. With telemetry, I would be getting my data with 433 megahertz radio. So the latency and my update rate is 150 hertz. So I'm able to stream live data from the drones. And finally, with respect to swarm, initially moving into any of the applications, we would be doing dynamic master slave setup, as sir explained earlier. So any one of these slave would take the master's position if the master is not operating as intended. And our concept of demonstration would be initially to hover in air at 5-meter position and altitude of all my 4 drones, perform simultaneous takeoff and landing, and finally perform formation flight, coordinated and synchronized cruise and loiter. So once we have this set up, so then we will be moving into the application demonstration. So as I mentioned earlier, so my companion computer will have its own set of sensors, and my flight computer will have its own set of passive and active sensors. So with companion computer, we have a CMOS high resolution cameras and ultrasonic sensor for obstacle avoidance, and we are either using lidar or hyperspectral cameras or infrared cameras. So depending on my type of application. LiDAR is specifically used if I'm mapping a corridor for traffic, but hyperspectral cameras come into picture when I'm doing it for the agriculture. So with respect to flight computer, I have my own set of sensors. For navigation, I have redundant 2 GPS systems to give me very accurate geolocations, and I have gyroscope, accelerometer, and barometer data to better fit into my flight computer. So my flight computer and companion computer would be interfaced. So any sort of decision that is done by the user is completely eliminated, and the companion computer would do the commands by taking in data from its sensor as well as the flight computer sensor. So with respect to our swarm drones, we are trying to leverage these pointers from our drones. So whatever image you are seeing is what we have developed to test our subsystems. So our subsystems here include communication and as well as autonomous control. So we are initially testing it out on a very standard 450 drone frame, where you can see we have a flight computer. Currently, we are using Raspberry Pi, and we are moving to Jetson as we progress further, and we would require more computational power. So here we are only testing the communication and the autonomous. As we progress, we'll be doing furthermore tests. So with all my 4 drones will have different assigned tasks. So this again, assigning task is either by a master in the autonomous mode or manually by the local operator sitting at the ground control station. And my drones will have drone-to-drone communication links as well as drone-to-ground control station communication link. Fail-safe system built into each of my drones, and large area coverage. Because we have high range capabilities, my drone-to-drone range itself is 5 kilometers. So I'd be able to cover a large area in very short amount of time. And again, as I stressed, this is always adaptable and scalable technology. So why do we think we visited GKBK and we saw drones are already doing their job of spraying fertilizers and doing mapping, geofencing, but why swarm is required, and how does that power over the conventional drone that are currently being used? So the first and the most crucial part is scalable and the area of coverage. So as per the data what we have collected from GKBK, we found out that in order to cover 1 acre of any field, a standard drone carrying a reservoir of 10 liters would have to do 3 rotations, and each rotation it has to land and then again repurpose and again flown back. So because we are operating drones in a group, so you would be able to do all of these tasks at a time without the need for reprogramming the single drone. And we'll have autonomous coordination, as I explained earlier, and redundant fault tolerance, enhanced data collection and analysis. So my drone 1 and 2, as I mentioned, will have advanced computer, NVIDIA Jetson to be precise, which has advanced computational capabilities. So I would be able to map, I would be able to detect, and I would be able to make a decision on my drone itself. So I don't need a ground control station as of now. So a drone 1 and 2 itself can make decisions and instruct the other drones to do whatever task it is intended for. And improved efficiency and responsiveness is again one more factor. My drone 3 and 4 can also be customized to have a larger reservoir by having slight bit of modification with respect to my motor propeller combinations as well as my frame design. So I would be able to adapt to the required changes in a fast pace. And cost effectiveness, initially setting up a swarm would be, initial setup cost would be a little bit higher for swarm drones when compared to conventional drones. But again, our swarm of 2 drones can cover 1 acre of land within 5 minutes, and I can have both my drones doing this spraying at a time. So this, at a long run, I would get cost savings compared to my conventional. Yes. Thank you so much. I think if you have any questions, I'd be happy to answer.
Okay, thank you so much, Dr. Tengli, and as well as Engineer Heron also, for giving a lucid picture of, we were thinking of listening to drone, then we could see the what could be the action of a swarm of drones. Now, definitely, we are having a different group of researchers involved in plant protection. I request them to pose some of the relevant questions for clarifications. With both engineers are here. And crop side, we have our own expertise, though we have not done much, though we have initiated, but had to go in a large scale. With this, we'll proceed with the small discussions. Over to anybody can start that one.
Can I? I'll.
Yeah. So please introduce yourself and.
Thanks for the nice presentation. I am Dr. Senthil Kumaran, working on mechanization, and of course, we all of many of the group has started the working to start the digital horticulture in this institute. So in this regard, I have two queries. I mean, in this swarm drones, is there any number limitation in the agriculture field? It's a number of drones. Is there any minimum or maximum limitation is there? This one thing. Second one, you talked about the layering system. If it can be explained, the layout, I mean, what called that flow chart, which we have used for the layering of drones, if it can be explained with an example of agriculture, so that would be nice. Third one, for the last one, the mapping and taking the photographs and analyzing it. What is the minimum number of photographs at the data? At least capturing the images, the number of images required for analysis. Thank you, sir. Any one of you, I mean, both.
Mr. Heron, you can go ahead. I think there is no number limited. Number can be more actually. You wanted to know minimum how much? Correct, no? Yeah. Actually, we started this with only 2 numbers right now. So we are going for 5 numbers now. Okay. So to have more other applications we want to incorporate, like that obstacle avoidance, that is collision avoidance, and other objectives to meet that. We are going for more number of drones. Otherwise, minimum 2 is required. So maximum can be, it depends upon the application point of view. Heron, you can explain about this layered approach.
Thank you, sir. Sir, to add on to the point of number of drones. So initially, my software allows me to control 8 drones at a time. So we can possibly control 288 number of drones. So that is possible. But the only concern here is my obstacle avoidance and collision avoidance. So because depending on the area of my field, I would have certain number of drones that would be assigned to do a task. So again, we don't have a limitation to number of drones. That can be any number. But the software what we develop would have limitations. So this, again, depending on the end user, we would be modifying the software. to explain the layered approach with respect to agriculture. Sir, currently, like whatever we saw in GKVK, so we don't see autonomous control that much when it comes to agriculture because it has its own risk factors, and most of the drones that we use currently in agriculture is manually controlled by a handled operator, handled remote. So in my decision making layer, so I have a ground control station software where I will have my map. So currently we are calling Google Maps every time we want to do mission planning. So in decision making layer, I would be assigning waypoints where I want my master drone 1 and 2 here specifically to do the mapping. So I'll pre-assign the required area where my drone has to fly and then do the mapping. So in my decision making layer, I do this, and then the masters, the 1 and 2 would do the mapping. So again, I'll touch upon the point how many data set is required. So currently, we don't have a specific number as of now, because if you can see the pigeon pod, so the amount of data that is required to train our model to accurately decide if that pod is infested, if there is a pod borer, or if the leaves are infected. So it is very sensitive. So we would say anywhere around 10,000, 10,000, 20, 30. So this can go up to 50,000 samples of images that would be required to train the model. And again, so next time when we go to GKVK, we are taking our drone to capture the data, because the data that is coming from a handheld camera or a handheld video camera is completely different, and the image that is coming from a drone is completely different. So this is one of the crucial part. So we want to collect the data from the drone itself, and then do the mapping, and then whatever data again we get from the mapping is itself used to train the model. So the data set, we don't have a number. It depends on the level of accuracy I would be requiring. So here we also want to differentiate into severity classes. So less severe, moderate, and highly severe. So in order to train the severity classes, you would be requiring 20 to 30,000 of images in each severity level of that particular crop or the field. And whatever the decision layer, whatever data I feed into the masters in the decision layer is done by the master initially, and then the master will geolocate in my control layer. In the task planning layer, my master will geolocate the area of infestation depending on my AI details. So it geolocate, and it would send the geolocation data to my slaves. So my control layer here is here I touch upon two parts: my communication layer as well as my control layer. The control layer, the master is able to make a decision where is the infestation, and my communication layer is able to send the data from the masters to my slaves. And in the application layer, my slaves will do the application, which here is just the spraying. Sir, I hope that explains.
Yeah, I mean, on the technical side is fine. Probably, yeah, when we really apply in the field, probably we'll try to understand better. Technically, whatever you explained is fine. I just thought of taking an example, say for example, a crop and a disease and identification and spraying. Anyway, that we can discuss. Thank you so much.
Thank you, and we interact also in future. As we progress, we'll be in touch with you, so you can also interact with us.
Okay,
Thank
sir.
you.
Thank you. Now,
Yeah, Sridhar, I have one question.
Krishna Reddy.
Yeah,
Yeah.
this drone application for monitoring, see whether pest or a disease. I give you specific example. One is coconut. If the drone is flying on coconut, the inflorescence and the fruits, if the damage is there, can drone record that perfectly? Is it possible? Similarly, in maize, in the bottom stem portion, borer is there or a disease spot is there. Can drone record those aspects?
Sir, when it comes to coconut tree, so this will make a little bit easier because again, we are using hyperspectral cameras here for only that purpose. With the visual cameras, it is very difficult to find out the infrared or infrared details or the specific details that are coming out from the specific given plant. So with respect to coconut tree, I would say, sir, it is a possibility. Again, my AI, the model, what we are using, the AI model has to be trained on that particular disease. So my AI my model should be able to understand if that is a normal or if it is a disease thing. So again, for coconut tree, it is definitely possible depending on how my model works out. So how many data set I would get and how would I train my model and if my model is accurately deciding. So that is totally possible with coconut tree, sir. And coming to the maize, if it is at the bottom portions, if there is a borer, this would make it specifically hard for us to actually map or see it, because again, the drones will give you a bird's eye view, but because again, it depends on the size of my drone also. I would not be able to fly my drone very close to the crop because it is again operated by a propeller, so I will have difficulties with respect to the control, or there could be collision over this. There would be collision or obstacle collisions. So with respect to maize, I would say, sir, it is difficult. Again, there is a possibility as we progress further and we come to an advanced level, we can have a fusion between the ground-based cameras as well as my drones in order to map out these kind of infestations or infections. So with drones, I would say, sir, maize is a very difficult job, but coconut trees would actually be a valid application for our small drones.
No, the coconut again, the same. See, the visibility on the aerial surface, if the camera is able to tilt 90 degrees, it is possible to record. Otherwise, even in coconut, it is not possible.
Yeah, maybe positioning of the cameras may have to be worked out. That is true. So in case of maize also, if borers are in the early stage, that may be possible. The only later stage may be difficult. Now, if suppose recent problems like fall armyworm, generally they will be coming in the early stages. At that time, it should be able to do. Maybe the borer problems which comes later stage may be difficult to detect, particularly the ground portion borers.
So that is the more important. See, the spraying, what is the initial introduction, crop health management, if it is able to detect the problem and then applying the spray. If it is not able to detect, how it can go for spray?
Correct, sir. The thing is, like again, like you mentioned, our cameras would be gimbal operated, so you'd be able to rotate it 360 degrees. So that is available. I would be able to. I can yaw my camera and I can rolling, yawing, and pitching is possible with respect to my gimbal that would be present on all the drones. And detection here again is very specific. So if I have to detect, because this is completely dependent on the model that I'll be using. So this is very specific to the disease. So in our case, it is pigeon pods, and the disease, the infestation is only pod borers. So this is very specific to the type of problem. So then I can take the data set, train my model, and apply to that specific, I would say, specific problem. So this is very application and end user specific, sir.
Now, even borer experience, I can say what you are doing with the pod borers. If the pod is bent, if the panicle is bent, how accuracy you are able to predict the borer damage?
Again, sir, like that solely depends on the type of data sets I'll be getting. So we have to visit GKVK again. So the pods are at very early stages. So we have to visit, collect the data set. And again, as I said, I'd be flying my drone at one specific altitude. And then from my gimbal operated cameras, I'd be collecting the data set. And then from then we would be able to make a decision on how accurately we would be able to detect the pod borers. So this is solely dependent on the type of data set I'll be getting and how accurate my model is. So because we also have option for manual control from a ground control station, a person, a very experienced local operator who knows how a pod, the infested pod or the pest looks like, can command my drone to do spraying at that particular area. That is also possible.
Hello.
Okay, that's Srinivas, yes.
Yeah. Haren, I have one question like,
Yes, sir.
suppose in cotton actually, the symptoms which is expressed by the insects, sometimes the diseases or the disorders will be almost the same. For example, if the cotton is infested by leafhopper, it ultimately leads to the reddening of the leaves, which we call it as a hopper bug. Okay.
Okay.
Then suppose if there is a deficiency of nitrogen and magnesium, that also leads to leaf to become red. Leaf becomes ultimately red.
Okay.
Then another case, suppose if there is a disease, maybe leaf, leaf spot and other things, leaf also becomes red.
Correct, sir.
Ultimately, leaf becomes red, but the control measures are different.
Okay.
When you take with your drones, the spectral images, how you apportion or how you separate it out, that this is due to leafhopper, where I can go for insecticide application, where you can go for the magnesium application for deficiency, or fungicide for the diseases like. So that's a real challenge. How do you do that?
Sir, I totally agree with your point, sir. This is very challenging again. So here we closely work with experts like you, because once I get my hyperspectral data from these particular plants, so I would look for any specific distinguishing factors, sir. Like you said, so with my hyperspectral camera, I would be able to find out that differentiating factor, and then learn my train my model to detect that specific the specific character. Then I would be able to make decisions. So this is again, like, we'll have to work with experts like you to get the data set, to understand the actual problem, what causes the problem, and what is the specific distinguishing factor. So this is again solely dependent on the
This is real challenge actually in the plant protection, and particularly when it comes to the precise plant protection in the precision agriculture, where normally our insect pests or diseases not uniformly be distributed, they are isolated, like more or less.
Okay, sir.
But if you want to take up, then and there only, wherever the pest is there, wherever the diseases are there, then and there only, if you want to take up a precise pesticide application, there we need to identify exactly, we need to apportion, which is that insect damaged spot, disease damaged spots, or both. So that way it is really challenging, because one of the company came to my department and we did a lot of exercises and they are doing it. And in fact, if you are interested, that we can also join hands with your institute, and there is one company which is ready to fund also.
Okay. That would be great, sir. I think Tengli, sir.
Yeah, in fact, I did.
Sir, actually, really, it is a very good challenging situation what you are saying, because right now what happens is it will only capture images, and then based on that it will decide.
Yes,
but in this case, with all these three problems, this image is going to be same as you said.
Yes, sir.
So that detecting that this happened due to what reason really needs to be known. For that, what is required to be done, whether any this sample analyzing, and after that taking decision what to do and all that kind of thinking has to go in, and then see how best this problem can be solved. I think this is really a first time I am hearing. This is really a very good challenging problem to take up.
Yeah.
If you say this that other organization who are really interested in taking up this, maybe they can interact with us. Maybe we can work together, because our team is very good in this kind of applications. But the only thing is the problem what you said, it is really a challenging problem, and we have to spray pesticide or this one only with respect to that particular problem.
Exactly.
Since these images are same for that, if we use a pesticide, then it may not work.
Yes,
So,
sir.
that really we need to take up this and then do. This is a really challenging problem. We can work, sir, this one. This we will
Sure.
try to see how best we can come out with solution. Maybe you can also tell other organization to interact with us.
Yeah, that's one part. In fact, I have already developed standard operating procedures for paddy as well as cotton insect pests, sir. So I already done. So 2 season data I have already. I have published the data. That's one
Yes.
thing. Yeah. One more question, sir. Probably to Prahlad, sir.
Yeah.
So the government has given a permission last year, February 2022. They have
Yes.
launched the Kisan drones, isn't it?
Yeah. Yeah.
What is your opinion, sir, in launching these drones for pesticide application or in total in agriculture? What's your view?
That we need to look into that, sir. Actually,
Now, why I asked this?
because they wanted to give importance for this crop, this one, and then they have launched.
I agree,
Yeah.
and I also attended that conference, which was launched by our honorable Central Agriculture Minister. I attended that, but what I felt was the drones are specifically now released for a pesticide application.
Yeah, correct. That is there.
Pesticide application. To apply the pesticide, we need to know its bioefficacy against insect pests, not for the phytotoxicity. The permission has been granted for whether the chemical is not harmful or harmful, just to test that they have given, not for how far the pest is going to be controlled. You got my point, sir?
Yeah. Correct.
The
Correct.
bioefficacy trial need to be done rather than they give permission for only the phytotoxicity studies.
Yes.
Using the same chemical, recommended chemical, already phytotoxicity studies have been proved.
Yeah.
That's what I told, but I don't know. The decision makers. I think it's too early to say that. For example, for paddy, for cotton, what is the level at which we need to spray? What is the quantum of water we need to use it? All those things we need to address and tell to the farmer, and need technicians to operate these drones.
Yeah, correct.
Isn't it, sir?
Yes.
So these are issues which I felt, it is probably early to say, at least the plant protection specialist.
As
Sir, that's what, sir. That's what.
True, sir.
That is true. Actually, that's what I was saying. Before spraying this pesticide, we need to know the present health of the crop. Afterwards, where to spray, and after spraying also, we need to monitor the health of the crop, not just like spraying. So for that, we need to continuously, we have to look into this entire crop and then see that whether that has given any benefit. I think that needs to be monitored also afterwards.
Exactly, sir. Exactly.
Yeah.
The very ultimate use of the drones is to reduce the drudgery in terms of cost, in terms of saving of the timings.
Yes.
So, keeping the pesticide control constant, in the sense same control has to be obtained, but the cost and the time has to be saved. That's what the main objective.
Actually, it has to be optimized, and whatever is sprayed has to be effectively used. Means wherever required only it should spray, and then that health of that particular crop should improve. So that's what we need to achieve at the end.
Yes, sir.
Yeah.
Yes, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you for giving opportunity. For
Anybody else? Just
talk.
final call, sir. Just anybody else?
Sir, as it was told that maybe we can work together, sir, in some of the areas, challenging areas, where we can also contribute from our end.
That's what, sir. I too feel like we can work together with ICAR-IIHR, IIHR, our Sridhar is there, a team of scientists are there. We can have the group of crops, and so that we can really work upon.
True, sir. As it is mentioned, the very purpose of this sharing of knowledge is to go forward even for the practical purpose. In the engineering side and the technique side, we are strong. Suppose Dr. Srinivas, he says he is ready with rice and cotton. Similarly, we have
Yeah,
just started for horticultural crops, and it is very pertinent that for each symptom and each disease and specific crops, that imaging should be very unique, so that these drones can identify easily. We can program them. After identification, they can spray. In that respect, definitely we need a collaboration to go ahead.
yes,
And
Yeah.
with this, you with our institute also already that is MOU is there. There only that period is over. We have to just renewal that. That can be done. The last time we
Yes.
were with the director also. That is
Yeah,
there won't be any problem. And as Dr. Krishna Reddy, Dr. Srinivas suggested, these are the practical problems. When you start this, instead of listing out all the major problems, but practically whatever is possible, once you start attending, one by one, you can track that. As that very pertinent that changing of the camera angle itself, it may be able to
Correct.
take the symptoms. Once that is there,
Yeah.
and earlier application of pesticides itself is a very difficult. Nowadays, suppose
Correct.
instead of a man climbing, if you send 10 liters, 20 liters capacity pesticides to the top of the tree, and if you position the spray nozzle in such a way, it can spray on the inflorescence of coconut or bunch of these coconuts. It can be improved when compared to the earlier. In that way, we can after this presentation, whatever points have come, they will help also to, while making protocols, we can keep them in mind, and we can go ahead further. With this, I thank both the speakers, Dr. Tengli and Herenji, nicely, very nicely, very few slides, but very nicely presented. The points of expectation from drones also it is there, and we can go ahead together and in making use of these drones, because once they are into market, they are suppose recently last month only one farmer was earlier regularly calling for pesticide recommendations, and one day he called, I purchased a drone. He started asking, well, how much, what pesticide, how much you have to use. He is want to use it in brinjal. That way, farmers started purchasing on their own. Means before that, we should have knowledge in first-hand knowledge in from our side only. For that, as early as possible, we'll work together and get ready with the information expected from the farmers. With this, again, I profusely thank Sir Dr. Prahalada for accepting this. Day before yesterday, were in Hyderabad. I know for receiving some DRDO award something, and being a last 125 months without any gap, we have been conducting these talks. I thought we are approaching 30th. 30th is holiday. How it is possible? 29th we are here. One is there. But with our cooperation, we could do it, and with a good topic. And from the side of our Association for Advancement of Pest Management in Horticultural Ecosystems in IIHR, once again, we profusely thank both of you, and we'll be in touch with you, and we'll work together for drones application. With this, I thank you profusely, sir.
Sir, actually, it was a really very good discussion, especially this question answers, whatever this questions asked by your scientist. Scientist, I am really very happy, because some of these real problems that was expressed, I think we need to, if possible, maybe we can make some few points of discussion like thing, and that can be shared to us also, so that we'll work on those things, how to overcome those requirements, because these are all the practical problems which are being faced. Always it is good to work to sort out the real requirements instead of just doing something on our own. So this is a really, I feel it is a very good discussion, and thank you very much for your giving opportunity to me to be today. And
I am thankful to you, sir.
No. Actually, it is a really a good learning also to us, and it was a good discussion from your end.
Yes.
And thanks to you as well as other scientists and other participants who have participated in today's talk. So thank you, sir.
Thank you, sir. Dr. Srinivas want to say something.
Lastly,
Okay.
lastly,
Yeah.
small suggestion, like In fact, such of the researchable issues can be given it to our PhD students, because you are also getting PhD students every year. And we too
Yeah.
have PhD students every year. Sir, we can
Yes.
think of giving it such of the problems to PhD students where we can, apply for some DST projects, fellowships, and so on. Those things we can explore, sir.
We can do, sir. We can do. That's what I said actually. We can do like that together.
Yes,
And
sir.
there is absolutely no problem. And we had MOU also with
Okay.
your institute. And last time I met your director also. He has given go ahead on this, and this point was also discussed with your director, and we have agreed already. And
Done.
absolutely there is no problem on this. We can do it together.
Done, sir.
Yeah.
Done, sir. Done.
Okay.
We'll do, sir. We'll work together.
Yeah. Yes.
Right.
Thank you, sir.
Thank you, Sridhar.
Thanks a
Thank
lot.
you,
sir.
sir.
Yeah.
With this, once again, as a formal vote of thanks type, I thank all the participants. First, the speakers, that Prahlad and that Heron, both of them very nicely explained. And now we are familiar with this, not drone only, swarm of drones. How to then I
It
thank
is a
that
teamwork, sir. It is like teamwork.
Yeah, yeah.
Earlier
Yes,
it was
using-
individual.
Right. Yeah. Right.
Using expertise of team. That is the
Team. Right. And then I also thank Dr. Krishna Reddy, Dr. Srinivas, and a lot of other scientists from IHR. And Dr. Girish joined from Pune, and Dr. Ramchandran, everybody, whoever joined in this talk, I profusely thank you all. And once again, thanking both the speakers. With this, we'll be ending today's talk, and we'll be meeting next month with a new topic. Till that time, thank you, everybody. Namaskar.
Namaskar. Thank you, sir.
Thank
Thank you very much. Thank
Thanks
you
a
all.
lot.
Thank you.
Thank you.
Yes.
I'm closing the meeting, sir.